Hi everybody, welcome back. We'll continue with worksheet problems, work energy power topic. Conservation forces are defined as the force for which work done depends only on the initial and final position. Of course, it is true. Work done depends on the initial and final position and also in the path. Conservative forces work done is independent of path. A and B are contradictory points. A is correct. Work done depends only on the path. Of course, wrong. Work done depends only on the initial position. So, thinking them in a proper way, which option we can take? Yes, option A is probable answer for it, for conservative forces and the conservative work. Next. A body of mass m is equal to 8 kg under the action of force is displaced according to the equation S is equal to T square by 4. Find the work done by the force in time in the first 4 seconds. Work done during 0 to 4 seconds. I have an idea for it. Work done instead of calculating force into displacement, because you have to go for acceleration and then force and then displacement. That's a long process. Have another idea. Why don't you go for change in kinetic energy? Yes, change in kinetic energy means half mv square minus half mu square. Of course, initial velocity is 0 here. Initial velocity is 0. Final velocity at the end of t equal to 4 seconds, you need to get it. Then you can substitute that in this. So for that, I am taking the advantage of this S. Velocity is equal to ds by dt. That is equal to 2t by 4 derivative. So that is nothing but t by 2 implies velocity at the end of 4 seconds is equal to 4 by 2 is equal to 2 meter per second. Wow. Now kinetic energy change is equal to work done equal to change in kinetic energy. So change in kinetic energy, that is equal to half mv square, half m value 8, v square value 2 into 2. So it will be 16 joule. Yeah, so answer is 16 joule. Hope you are with me. Next. A block of mass m traveling with velocity v1, a block of mass 4m, I can take it as 4m, traveling with a velocity v1. So u1 is equal to v1, I can take along x direction. Okay. On a frictionless horizontal plane makes an head-on collision with another block m2 is equal to 2m, traveling in opposite direction u2 is equal to minus sign v2. Okay, traveling with velocity v2, he said. Minus sign is because of opposite direction, opposite. So keywords must be noticed strongly. With a velocity v2, after collision both the blocks travel as a single one. That means it's a perfect inelastic collision. Then final velocity is v, final common velocity is 5v2, they said. Okay, ratio of v1 by v2 he is asking. We have a common velocity is equal to m1 u1 plus m2 u2 by m1 plus m2, total momentum by total mass. So common velocity 5v2 is equal to m1 u1 is 4m into v1 minus 2m into v2 by m1 plus m2, 4m plus 2m. So here it is 4m v1 minus 2m v2. Why am I writing same step again? We'll simplify a little, that will be better. 2m you can take common so that it will be better for us. So 2m if I can take common, this will be 2v1 minus v2 by 6m. So mm gets cancelled. So this will be 3. 2 also gets cancelled. Let me change the color so that it will be better for you. Once and here thrice. And this is 5v2 as usual. So what I can write, 5v2 is equal to 2v1 minus v2 by 3. So 15v2 is equal to 2v1 minus v2. So 16v2 is equal to 2v1. And then we want v1 by v2. v1 by v2 is equal to 16 by 2, that is equal to 8 by 1. Okay, option D. Yeah. So common velocity formula is m1 u1 plus m2 u2 by m1 plus m2. Next. If a force F is applied on a body and it moves with a velocity v, the power will be force into velocity. Next. A particle is moving along an x-axis has potential energy U is equal to 2 minus 20x plus 5x square along x-axis. Okay. The particle is released at x is equal to minus 3. Okay, fine. Maximum value of x is, the particle's potential energy will be converted into kinetic energy completely, that is one extremity, right? So that extremity I want to calculate by equating it to 0. So that 5x square minus 20x plus 2 equal to 0. 5 2s are 10. So it won't come with 20. So x is equal to minus b plus or minus square root of b square minus 4ac minus 4 2s are 8, 8 5s are. Okay, I'll write 4 5 2. So it will be 40, 360. Yeah, 360 by 2a. 2a means 10. So it's almost all coming as 3.9. 3.9. X equal to 3.9. Then he is asking maximum value of x. Okay, this solution is, but it is released from minus 3. Minus 3, its magnitude is 3. So maximum value of x is modulus of minus 3 plus 3.9. So it's going to become 6.9. Nothing but 7. So it is from 7 meters onwards. Next. A man who is running has half the kinetic energy of a boy. Man, mass. Capital M I would like to take. Baby mass, that is boy mass. Boy mass, small m. A man who is running has half the kinetic energy of a boy of half of his mass. That means, and small m is equal to boy's mass. And half of the man's mass is boy's mass. Wow. Now this velocity, this kinetic energy, half m v square is equal to half of kinetic energy of the boy. Okay, that means 1/2 will go. Now mv square is equal to half mass of the boy is m by 2 into v square. So again m and m also gets cancelled. So v square is equal to v square by 4 implies capital V is equal to small v by 2, representation 1. So first line we read and we got a representation. Now the man speeds up by 1 meter per second, then they have same kinetic energy. That means half m v plus 1 whole square is equal to half m by 2, boy's mass is m by 2 into v square. So here half m by 2 will go. Then v plus 1 whole square is equal to v by root 2 square. Is it correct? V square by 2. Yes. So implies v plus 1 is equal to v by root 2. V plus 1 is equal to v by root 2. Yes. What is v? V is equal to v by 2 we have. That I can replace v by 2 plus 1 is equal to v by root 2. Okay? Yeah. I want v. So what we can do betterly is v by root 2 minus v by 2 is equal to 1. What I did, v by 2 I took on one side. Then v is of 2 minus root 2 by 2 root 2. Just I took the LCM equal to 1. So v is equal to 2 root 2 by 2 minus root 2. Even on taking here all are numerators only, not fractions. So 2 root 2 rationalization. Then this is multiplied with a plus b. Then what will come? This will be a square minus b square. So that means 4 minus 2 will come. In the numerator 2 plus root 2 will come. So rationalization implies. That means 2 will go. So it will be root 2 of 2 plus root 2. Am I? Yeah. Option. Yes. Next. A motor engine pumps 1800 liters of water. So mass is equal to 1800 kg. 1 liter equal to 1 kg for water. And volume V is equal to 1800 liters. Per minute, time T is equal to 60 seconds I can take. From a depth of a well, D is equal to 30 meters. Sometimes we'll write it as H. And allows to pass through a pipe of cross-section area A is equal to 30 centimeter square, 10 power minus 4 meter square. So that should be noticed. The power of the engine is, power P is equal to, it is just lifting water per minute from a well of depth 30 meter and allows to pass through a cross-section area of 30 centimeter square. So that means it will have some velocity also. That also we need to observe. So volume rate is equal to cross-section area into velocity. Volume rate equal to cross-section area into velocity. Volume rate is 1800 liters. 800 liters. Liters means 10 to the power of minus 3. By time is 60 seconds. 60 seconds. Volume rate equal to cross-section area 30 into 10 to the power of minus 4 into velocity. Into velocity is yes, that is velocity we need to find out. So 10 power minus 3 will be, this is 10 power minus 3. 10 power minus 3 goes. And 3 will go one time here. 3 20s. Okay, 3 in the numerator we will cut. Why to cut here? It shouldn't be, no? Or otherwise, why to go for a direct step? We'll have another step. Yeah. 1800 by 60 into 3 is velocity, that is equal to 180. So V equal to 10 meter per second. In SI units only we took everything. Now power is equal to mgh plus half mv square, total work done by time. Total work done, m can be taken common, so that gh plus half v square by t. m 1800 into g 10, h 30 plus half v square 100 by t is 60. Yeah, 60 0 will go, 6 3s are 18, 30 into, this is 300 plus this is 50. So 350, okay, 0 So it is 10.5 kilowatt because it's a par. So 10.5, third option, huh? Yes. Next, a bead of mass 400 gram. Bead of mass 400 gram. 400 gram into 10 power minus 3 will be kg. Yes. Moving along a straight line under the force that delivers a constant power P is equal to 1.2 watt. Okay. If the bead initially at rest and finally how much speed it attains after a time t equal to 6 seconds. Yeah. Power is equal to work done by time, that is equal to change in kinetic energy by time. So initial velocity 0, initial kinetic energy 0. So final kinetic energy half mv square is equal to power into time. So half m value, okay, we will establish a formula first, later we'll substitute, that will be better. So v square is equal to 2pt by m. So v is equal to root over 2pt by m. Let us substitute now onwards. So with another color. Yeah. Velocity v is equal to root over 2pt by m, 400 into 10 power minus 3. 10 power minus 3. Yeah. So it will be 400 here. 4 table I cut. 4 table 0.3. Okay. Then it will go as 0 zeros will go. 1 0 will be left. That will be 3. 3 2s are 6. So 6 will come. 6 meter per second. Option C. Yes. Next. A man of weight 50 kg carries an object to a height 20 meter in a time. Let us write the data. A man of weight 50 kg, but kg unit is for mass. So m is equal to 50 kg. Carries an object. Okay, objects. Then we will take one thing. Man mass capital M we will put. Man of mass capital M. Object small m, we don't know. Object small m. Okay. Next, height h is equal to 20 meter. In time t is equal to 10 seconds. The power used by the man is equal to 2000 watt. Then find the weight of the object carried by the man. Okay, this one only question mark actually. Oh, fine. Par is equal to rate of doing work, nothing but mgh by t. But here, see, if I'm trying to carry some load to certain height, I have to carry my weight also, right? So I have to consider m plus m into gh. So m is 50 plus m I don't know, and g value 10 and h value 20 by time 10. So here par 2000. Okay, now it's a simplification. Let me take another color. I usually change the colors like this, and then 2000 here, 10 here, 10 here gets cancelled, 2 also gets cancelled. So 100 is equal to 50 plus m. So m is equal to 50 kg. Wow. Hope you are with me. Next. A smooth chain of length 2 meters is kept on a table. Here I will draw a picture. A smooth chain, chain of length 2 meters. Okay. Length L is equal to 2 meters. Okay. 60 centimeters is hanging. Hanging length is 60 centimeters. Okay. Edge of the table. Total mass of the chain is 4 kg. Total mass m equal to 4 kg. Okay. The work done in pulling the entire chain onto the table is. What is initial potential energy? initial potential energy U is equal to minus mgh minus, what is m? M is mass of the chain that is hanging. You see, total mass 4 kg. That means 2 meters, 200 centimeter chain is having 4 kg. Then 60 centimeters will have how many grams or how many kgs? 4 by 200 into 60. 4 by 200 into 60. This is mass. Into gravity 10. Into height. At the center of mass, the potential energy will be stored. So that is 30 centimeters only. Half of it only we have to take. So 30 centimeter, 30 by 100. This is initial potential energy. And final potential energy 0. Difference will give you work done. Work done is equal to final minus initial potential energy, that is equal to, I'm taking the magnitude, that only you need to do the work. So 4 into 60 into 10 into 30 by 200 into 100. So 1, 2, 3, 1, 2, 3. Okay. Next. 4 into 6 into 3 by 20. 2 table 2 times. Oh, why? 4 table directly will go now 5. So this 2 also gets cancelled. Okay. I will write like this. Yeah. 4 ones 5 table. Next in point numbers. Okay. 18 by 5. That means 3 point something should come. 3 point something. Yeah. 3.6 joules. Yes. Okay. Next. A 1 kg ball moving at 12 meter per second, m1 is equal to 1 kg, u1 is equal to 12 meter per second, collides with a 2 kg, m2 is equal to 2 kg, ball moving in opposite direction, u2 is equal to minus 24 because opposite direction meter per second, coefficient of restitution is equal to 2 by 3, then velocities after the collision. First options, second options are matching, similar are there. So we need to do both. V1 is equal to, I'll write the formula in a different rate, typical way. You try to observe that. M1 minus M2 by M1 plus M2. It is not for semi-elastic collision, elastic collision. Variety way I am writing, you see. U1 plus dash M2 by M1 plus M2 into U2. Here I would like to give some magic. That is, sir, here 2M2 should come, sir. No, 1 plus E will come. Here EM2 will come. So this is for semi-elastic collision. So let me substitute the values. M1 is 1 minus 2 by 3 into M2, that is into 2 by M1 plus M2, 3 direct. U1 12 minus plus I can, okay, 1 plus E 1 plus 2 by 3 into M2 2 by M1 plus M2 3 into minus 24. So it's a simplification. 3 will be here. 3 minus 4 is minus 1 by 9 into 12 minus 3 will be here. 3. So 3 plus 2 5. 5 2s are 10. 10 by 9 into 24. So its further simplification will be, I'll take another column, another place I will write. Yeah. So 12 also can be taken common. Yeah. 12 on taking common, minus 12 on taking common, minus 12 on taking common, 1 by 9 minus 10 by 9, no, 20 by 9, plus 20 by 9, because I took that one common, 21 by 9, minus 12 into 21 by 9. So 3 table 3 4s, 3 table 3 3s, and 3 1s, 3 7s. So it is minus 28. So first option minus 28 is only at one place, that is option B. So option B correct only, but I'll give you V2 formula also so that you can betterly enjoy that. V2 formula also I will give. V2 is equal to 1 plus E into M1 by M1 plus M2 U1 plus, yes, M2 minus EM1 by M1 plus M2 into U2. On substituting, you will get V2 is equal to minus 4 meter per second. Okay, yeah. Next question. During inelastic collision between two objects, which of the following quantity always remains conserved? Always remains conserved is total linear momentum. Energy is conserved only in elastic collision. In inelastic collision or whatever be the collision, in all kinds of collisions, linear momentum is conserved. All kinds of collisions, linear momentum is conserved. Yes. Next. A motor pump lifts 6 tons. M is equal to 6 ton. Ton means 1000 kg, right? Quintal means 100 kg. 1000 kg, ton. And this color will be good. Water from a well of depth D is equal to 25 meter. To the first floor of height 35 meter. So first floor of height 35 meter. Total 0, 1 here, 60 meters. Next, from the ground floor in 20 minutes, time T is equal to 20 minutes. 20 minutes into 60. Whenever we notice other unit, we should immediately activate our brain. Hey, this is not SI unit like that. Then power is equal to mgh, work done by time. So m 6 into 10 to the power of 3 into g10 h 60 by time 20 into 60. Yeah, here he is asking kilo, so I will write it as watt, and from now onwards kilowatt. That means 10 no 6 60 gone. 60 by 20 3 kilowatt. Only 3 is answer. Yes, 3 kilowatt. 1000 I took as kilo. Then there ends the matter. Next. Kinetic energy of a body of mass m is equal to 4 kg and momentum p is equal to 6 Newton seconds. Yes, Newton second is the unit for momentum, not newtons. Newton is for force. So he is asking kinetic energy. So kinetic energy equal to p square by 2m. So p square 6 into 6 by 2m. M is 4. So 2 1s, 2 3s, and 2 2s and 2 3s. 3 3s are 9 by 2. 9 by 2 means 4.5. I just checked the options here only. Yeah. Next. A particle of mass m moving with velocity v collides with a stationary particle of mass 2m. A particle of mass m collides, m1 is equal to m I will take, and m2 is equal to 2m I have to take, and moving with velocity u1 is equal to v and collides with a stationary, so u2 equal to 0, and they stick together and continue. Common velocity equal to how much? Common velocity is equal to m1 u1 plus m2 u2 by m1 plus m2. m1 u1 m into v plus 0 by 3m. So that is equal to v by 3. V by 3 is the answer. Yes. Okay. Next. So this is the end of this work energy power session, and we'll continue with another chapter.